Good afternoon. Thank you for Chairman to Dr. Ekalina. So I would like to talk about today's concentration is oxidative DJ1 protein in eukaryocyte useful for the diagnosis method of Parkinson's disease. So, so Parkinson's disease is also, this slide shows a symptom of Parkinson's disease. So this is like a masked face and the rigidity or some tremor is very famous. But recently in Parkinson's disease pathology is, so characterized as severe loss of substance nigra and dopamine neurons. Basal brain, the section to substance nigra in the midbrain here. So it is estimated approximately 60 or to 70 the SN dopamine cell are lost of the time in the patient first present for clinical evaluation to diagnosis and treatment. But more first clinically too difficult to pick up the pathology. So like imaging the summary to this slide show the Brack's theory. So Brack staging refer to a method to use a clinically degree to a pathology. So stage 1 or 2 is a more stage 1 or 2 is more preclinical side. In this is Lewy's body is midbrain or olfactory bulb, but stage 3 and 4 is a clinical Parkinson's disease caused in a more wide side in olfactory bulb cause degeneration and Lewy's body is accumulation. And third stage is stage 5 and 6 is a cognitive impairment caused in brain cortex and cause a neurodegeneration. So this slide shows that the natural history of Parkinson's disease. We would like to diagnose to more than first time. So maybe this is recently caused in the diagnosis is here, but more first, earlier than stage, I would like to diagnose the Parkinson's disease. So, and also, differential diagnosis of Parkinson's disease is like essential tremor and progressive supranuclear palsy, PSP, and multiple system atrophy, MSA, and cortical degeneration, CBD, and diffuse Lewy's body dementia, LBD, and many Parkinsonism causing the disease. But different in difficult is Parkinson's disease and different Parkinsonism disease. So how to diagnose this Parkinson's disease? One of marker candidate is myocardial MIBG scintigraphy in Japan. So the myocardial MIBG update collected the clinical phenotype of PD. So in Japan, is recently used is many imaging diagnosis. So this slide shows a MIBG scintigraphy. So this is a left side figure to this one is healthy volunteers. You can see heart healthy volunteer. So maybe you can see a heart is pigmentation, but so this is actinic digit PD is gone to heart image to go on. So this is uptake, MIBG uptake is different. So recently is Japan could be used many hospital in Japan. So how to, this one is like no image into the M, so maybe a middle stem is M, then the ventricular cavity, so maybe a heart is, maybe ratio is important. So, you know, this MIBG is a 27 age man, to this one is healthy, and this one is a patient. So maybe H and M ratio to 1.25 and 1.35. So image is level is down. So maybe before, okay. So this is M and H ratio is usually to a 2.0, like a 2.0, but so patient is maybe early image to 2.25, so 1.2 and 1.1 to a very level is down, so half time. So sensitivity to spectral MIBG scintigraphy in Parkinson's disease is many published data to maybe N is 45, 68, 70, 291, so it's many. So maybe sensitivity and specificity is very close here. And also diagnose is control and PD and SND, PSD is different ratio to maybe close to 1.2 and 1.6, but control is a 2.0 or like this. So also the PD, SND, PSD is the same, different. So, okay. So how to diagnose Parkinson's disease? But so candidate gene is related protein approach to our synthetic. So we can check in autosomal dominant Parkinson's disease is some some gene symbol is a UCH1 or LAC2 or SNA or something like this. And also recessive Parkinson's disease is Parkin or PINK1 or DJ1 is like this. So DJ1 is mechanism is mutation of DJ1 gene in the mutated DJ1. In the active, so familiar disease is caused in mutation DJ1 gene, but sporadic stress, sporadic pattern to oxidized stress, and like this to cause the DJ, inactive DJ1, and the cause to the Parkinson's disease. You know, DJ1 is a PAX7 and cause the gene and encode the ubiquitous and highly concepted protein, and that may be play to lower the oxidative stress. So cause the gene, okay, so maybe two mutation is caused. This one is the deletion and several exons, which prevent the synthetases is protein, and point mutation in the highly cause the L1.6SP and make the protein less and able to promote degeneration through the ubiquitin proteasome pathway. And the recent autosome amount of the protein DJ1 the low were absent in the less. So this is this slide show that in DJ1 and oxidative DJ1 is maybe a GSH is down, and DJ1 to a chain to oxidative DJ1, and include oxidative stress and the stress resistance in the 6 OHDH. So we can make in oxidative DJ1 to pick up the two-dimension DJ1 of oxidative stress is 2 electrophoresis Western blot analysis in the anti-Park7 antibody. So PC12 cell to a control and the native, and the oxidative one is here to maybe some pH is different, you know. And also SHSY5 cell is mean to a neuron cell, neuron-specific cell, so maybe PC12 cell is different, but native and oxidative DJ1 to different. We can see, you can see check one protein. So primary neuron cell is control, and the OXDJ1 to a different size, it's 2-dimension. And also, so cysteine is 1.6 in the most sensitive cysteine reduced to H2 oxidative stress. So oxidative DJ1 to this one here, so maybe mass chromatograph, so this one show that. And also different this one to check in also we can see. So preparation to anti-OXDJ1 antibody. So maybe we can see 2 anti-OXDJ1 antibody, but so more sensitive is 1.6 in cysteine. So this anti-OXDJ1 antibody Western blot analysis is the same slide, so maybe native, oxidative, and this one is only anti-oxidative DJ1 to only one to this one check this. So maybe more specific in OXDJ1. So this is make a ELISA system to make using the anti-OXDJ1 antibody to this one C1.6S and DJ1. And OXDJ1 is more sensitive, you can see. So this OXDJ1 ELISA system is counting in some Parkinson DA in the mouse, the animal model with MPTP with model mouse. So this is 3 days, 1 week, 10 weeks in MIPT treatment. So maybe control or something like this. So like this one to check in oxidative DJ1 level in the eukaryocyte, red blood cell site in the MIPT treated mouse. So maybe same, almost the same in progressive the time 2 weeks. OXDJ1 level is higher than the same, this one to 15 or 15, 12 or 45 milligram to this in like this. So also staining the substance Nigua obtained from mouse and detecting OXDJ1. So this is control or like a 1 week and 4 weeks and 3 months is very different control. This is like this. And also rat injection to 61, and this is control, and OHCS is 2 weeks in change, this one. And it is same data to OXDJ1 in level in the eukaryocyte with the 6 OHDA treated rat is same one to elevated. So next, and we can try to human in check in average to OXDJ1 level, so eukaryocyte. And this is only 13 Parkinson disease, and 10 is a Parkinson disease, and 17 control. So maybe different is medicated. Some L-DOPA or some agonist patient is different. In a non-treated patient is different average too. I don't know, so but very interesting data. So this is a clinical ER stage and the OXDJ1. So this is a untreated group, and this is a treated group, medicated treated group. It's different, but so relationship is OXDJ1 level, and ER is an patient is unclear, but period. So maybe treated period is and OXDJ1 too. This is left side is a treated period, 2 months, and the OXDJ1 to a level is here. So maybe untreated PD to a more higher than, and the medicated PD is more lower than. I don't know. And next slide, this slide is OXDJ1 to and MIBG scintigraphy. So some group is different. So maybe before I say in MIBG scintigraphy, H and M ratio to cross over the 2 is a control, like a control. And this is 1 here to maybe down to Parkinson's disease. And also OXDJ1 to show that in this is here to some different is what I don't know. So some arrows 2 cases after decide is first time it decides Parkinson's disease, but treated after the progressive disease is maybe PSP, change in the diagnosis is change. So more over and different between to PD and the PSP and the MSA group we can show the more control and PSP MSA in the control is maybe age matched or moreover to like this. So MSA group and the PSP group is some difference between two Parkinson, untreated Parkinson disease and PSP to make it different between two here. But some Parkinson disease not elevated, you know. So I don't know, some Parkinson disease is not elevated. Some Parkinson disease is more higher. So this problem point is OXDJ1 biomarker to make recently is here. So maybe overlap in some present in here. So maybe future is more different sizes. I would like to try it. So in now, this slide, there are 2 main problems in OXDJ1 biomarkers. So has overlap to the control and move it and elevate it to some PD case. And second, in the PD medicated group is down to regulated OXDJ1. So, and after we can check in some higher level to Parkinson disease group is pick up the more clinical data, we can show that. So case 1 and case 2 and case 3 and case 4. In the first time is a more higher. A second time is a treated in a Parkinson drug. So maybe down and down and down. So, and like a SPECT in the PET, in the MIBG is maybe like this, and diagnose some cases cross the DLB, Lewy body disease, so like this. So Parkinson disease with dementia is PDD and DLB to overlap disease recently, and PDD later, PDD earlier, DLB earlier, defibrillator in the AD. So different in overlap disease dysentery like this. So I think is higher than level is DJ1 group patient is maybe PD and dementia or DLB. I don't know. So maybe a more research is and more future is a diagnosis. This one or this one, so elevated to 4 cases in clinical. So yes, this schema to cognitive impairment in Lewy body disease, and I think is some cases higher than the level in a patient. And just a moment. So last 2 slides. So this is a PD pathway to DJ1 and ubiquitin system, and the mitochondrial pathway to now is 2 big pathway to in the Parkinson disease. Our DJ1 OX DJ1 to higher level to some this one is caused to Parkinson disease. We can see so more. Easier to OXDJ1 elevated mechanism is a different pathway. So maybe I think it's some pathway to a ubiquitin pathway related gene, some pathway to a mitochondrial like a related gene. So this is pathways dysfunction in the same PD symptom. So maybe some Parkinson disease, big one to some group is OXDJ1 elevated in the PD or something. So I don't know in the future. So this is conclusion to this session, to today's presentation. Review of Parkinson's disease biomarker candidate, and one of the important biomarker could candidate the OXDJ1. Thank you for attention. So this is almost people in university Department of Neurology in the people, and biomarker or biological research is maybe Doshisha University, and like Saito, Dr. Saito is very encouraged to this research. Thank you for attention.
I'm just curious, perhaps you remember there was a paper about the DJ1 was associated with tau pathology that colocalized to inclusions. And the question is, do you know if, in fact, it's not just DJ1, but oxidative form of DJ1 stick to the tau? Because it's one of the mystery why genetically tau associated with Parkinson's disease, even though there is no link. What do you think?
Yeah, so maybe good question, but I have no idea. So because it's OXDJ1 to you show the 2D dimension to okay. So you mean in this one? So maybe OXDJ1 is an antibody to only one spot, but DJ1 to you can see other spot is recognized, you know. So maybe combined different protein. So some answer is this one. You understand? So maybe unknown protein is recognized DJ1, only DJ1, but oxidative DJ1 is maybe anti-DJ1 and anti-OX-DJ1 to only one to oxidative stress. I don't know. Yeah.
Any other questions?
So I have a question that is not directly related to your presentation, but you mentioned something about this. Well, so do you think that the impairment of cognitive functions that is always the secondary event when comparing cognitive results?
Yeah, so I don't know.
I believe.
Yeah, yeah, so very interesting. So, you know.
In all the cases, ありがとうございます。
Thank you. どういたしまして。ありがとうございました。